Hello everyone. In this video I will explain how to find out VC dimension for a hypothesis class, and we will also see what is VC dimension. So first let's assume that we are having two data points. Okay, and these data points are classified according to some logic, and we are having total two classes. So these classes we can represent with label like a and b, or true or false, 1 and 0, yes or no, and we are using these two colors to represent them, red and green. So if someone asks you to label those two data points in all possible ways, like you can color them one green one red, you can color both of them as green, both of them as red. So what are the total number of possible ways? So if we are having these two data points and we have to represent all possible way in which these two data points can be labeled, so there will be total four cases. So as you can see, in the first one, this one is red, this one is green. It means this data point belongs to one class, this one belongs to another class. Here both belongs to, let's say, class A. Here both belongs to class B, and this is also the same case but in reverse order. So for two data points we will be having four cases which can represent all possible ways in which these two data points can be classified. Now, when we need to find out a VC dimension for any hypothesis class, let's take line. So how to do that? So before going in detail, let's see, if we are having three data points and we are asked to label them in all possible ways, so what will be the number of those ways? So in the first case, we can label all of them as class a, same class, and this will be the case. So in this way there will be 8 cases. Okay, so the thing is that in case if you are having n data points, what will be the number of ways in which those n data point can be classified into two classes? So it will be 2 to the power n. Okay, so if we are having n data points, those data points, if you want to represent in all possible ways, so there will be 2 to the power n different ways. Now let's understand this concept shattering, because you might have seen this concept, this word, in the definition of VC dimension. So let's say a hypothesis class H can shatter n data points. So when we say hypothesis class, it can be line, square, rectangle, circle. So there are multiple hypothesis class. So let's take a simple one, line. So in a hypothesis class, it means, let's say, line can shatter n data points for which we can define a hypothesis. So in line class there will be infinite number of lines. So when you select a particular line, it means you are selecting a particular hypothesis that separates the positive example from the negative for every problem. Then we say H shatters n point. So let's take a example, then it will be more clear. So let's see, we want to check whether line hypothesis class can shatter two data points or not. So the total number of data points we are having, two. These are the all possible ways in which these two data points can be classified. Now, can we draw a line here which can separate one class to another? So it's very easy. You can draw a line in between these two data points, and you can say all the points falling in this side belong to class green and this side class red. Here, can you draw a line which can classify green class from the red class? So there is no red data points to you can draw a line easily, and you can simply say all the data points falling in this region belong to class green. So in the similar way, as you can see here, for two data points, a line can successfully separate a positive example from negative example, or we can say class A example from class B. So we can say line hypothesis class can shatter two data points. Okay, so let's check whether this applied for three data points or not. So in case of three data points, there are eight possible ways in which these three data points can be classified. Okay, so can you draw a line here which can separate green from red? We can easily draw. In this case, we can easily draw. This can be done easily. So for every case, we can draw a line which can separate one class from another. Now there is one important note you need to remember. And what is that? When we talk about shattering, so here I'm saying that for these three data points, I can draw a line in every case which can separate class A from class B. So why I have selected only these three data points? If you take an example of a data points which lie on a line, let's say three data points on a straight line, so in that case you won't be able to do this thing. So the point is that if you can find out even a single sample data, like here in this two-dimensional space we can have infinite number of data points, and if you can find out a simple sample, so we are considering these three data points as a simple single sample. Okay, which if we apply this shattering concept, our line can successfully can shatter these three data points. Okay, so it's not that when we say a line hypothesis class shatters three data points, it doesn't mean that every possible combination of three data points can be shattered by a line. No, this is not the case. If you can find out a single sample of three data points which can be shattered by a line, then you can say line hypothesis class can shatter three data points. Okay, so you need to remember it. This concept doesn't apply on every sample that exists in that space. No, if you can find out even a single sample which can be shattered by this hypothesis class, then we can say shattering is there. This hypothesis class can shatter those three data points. Now let's see whether a line can shatter four data points or not. So this is the note. Okay, so now let's okay, so that note part I have already explained it, but here this is an example as well. So if we take three data points on a straight line, so in this case, and if we classify all these three data points in all possible ways, so in this one and in this case, in these two cases you cannot draw any line which can separate green example from red one. So it doesn't mean that line cannot shatter three data points. This is only for one case. Okay, but if we take set of these three data points, then this is applied. So if our shattering for our shattering concept we can find even a single sample of data points, this is done. We can say that our hypothesis class can shatter those data points. So here, so this is the case. Okay, like in this space, in this two-dimensional space, if you can find out any three data points which can be shattered, then we can say hypothesis class can shatter three data points. So line can shatter three data points, remember that. Now let's see what is the case for four data points. So for four data points, if we label all data points in all possible ways, so we are having two classes, class A or class B, and if we classify these four data points in all possible ways, we will be having total 16 cases. And out of these 16 cases, case 3 and the last third, for these two cases you cannot draw any line which can separate green data from red data. And this is not the case for this data sample. In this two-dimensional space, you cannot find any combination of four data points which can be shattered by line. So now we come to VC dimension. So what is VC dimension? VC dimension of a hypothesis class H is the maximum number of data points which can be shattered by H. So in our case, we have taken line hypothesis class, and we have seen that for line the maximum number of data points which can be shattered is 3. So for line hypothesis class, VC dimension is 3. Okay, so this is the concept of VC dimension, and we have seen how to find out it for line hypothesis class. Thank you very much for watching.